Hello, Calculus. We're watching this after Monday's class, and that must be the 20th, and we're still in review mode, coming up upon a test. And it looks like I have a couple questions to add. I had 12 previous review questions, and I'm going to add 5 more. So, let's find the average value on this interval that this function takes on. And in order to do that, I will remind you that you will use this formula. If the function is continuous and differentiable. So always check that. So hopefully that'll give you a start on that one. Number 14 is use the limit definition to find this integral. In order to do that, there are some keys to the kingdom here. And let me see if I can get them all in the screen. Alright, so here's the integral, and we're going to do it the long way with the limit. We're going to take an infinite number of rectangular boxes and find the exact limit by letting the number of boxes go to infinity. So, and in the middle of that, these keys pop up, and I'll give you those keys on the test or on the board. You don't have to memorize those. They won't stick that long anyway. So, in order to do this one, we ended up taking the limit as n went to infinity, or as the width of each box, the norm, went to 0, same thing, from I equals 1 to n. So n's going to go to infinity, so we'll have an infinite number of boxes, and the height of each box was the value f of x sub I at the function. And then, I think we didn't call it x, we called it c sub I, and we'll improve on that. Alright, and then we did times the width of each box. So the width of each box is b minus a divided by n, and n's going to go to infinity, but that is going to be, in this case, our b is 6 and our a is 1, so we're going to 6 minus 1 is 5 over n is what we're going to get in this particular case to put in here. But before we multiply that through, we have to take the function at each interval along the x-axis, and c sub I is going to be a plus change of x sub I. So in this particular case, c sub I is going to be a, which is 1, plus, this one turned out to be what, 5 over n we said, plus 5 over n I. Alright, so that is going to go into the function. So it's going to be 9 times this quantity squared plus 2. So we're going to mess with that and simplify that, and then multiply the 5 over n, which is sitting here, through to that whole thing. I don't know if you follow that, but look at some of your older examples, and I'm sure you will. So, again, this is our guiding light here. And in the middle of all this, you're going to find the keys to the kingdom will pop up, and they will help you find limits that you can take, and it'll end up with a number at the very end. It will be the exact limit. Alright, so good luck with that. At least start setting it up. And then I gave you a practice one, finding upper and lower and midpoint boxes to find the area between this curve and the x and y axis, and make 4 subintervals. Alright, that one's pretty straightforward, but I want you to do it 3 times. One with upper sums, one with lower sums, and one with midpoint sums. Alright, so the lower sum should be a little below the real area, the upper one above, and the midpoint should be in between the two. Alright, and this one is find the derivative of an integral. That's going to be using the second fundamental theorem of calculus, and recognize what happens when this is an x. It's a function in x. So don't forget what to do with that. And on the last one, review 1. We start not at a constant but at x. So we have a trick up our sleeves. In order to use the fundamental theorem, we have a trick that we apply to calculate this one. This says from x to x cubed. That's what that says. Alright, so I want you to either be working on some of the reviews, the earlier review questions 1 through 12 if you haven't gotten those done. And if you have, or you don't have those with you, start on these. So I want these all completed to some degree of mastery before we take the tests, hopefully on Wednesday. Alright, that's to be discussed. Alright, that's it for tonight. Copy these down and get to work. Goodbye.